the amplifier loaded just a little bit extra heavy, a little heavier than the normal operating range in order to assure excellent linearity. The very best linearity comes with a slight sacrifice in efficiency, which is no problem because the 87A has plenty of power supply and thermal capacity to handle that slightly reduced efficiency. We could probably get 70% efficiency if we run it right on the ragged edge, but we would sacrifice some linearity by doing so. Now, with the amplifier operating at right just about the 1500 watt output level, let's just check it, demonstrate a couple of other features here. Take it down a little. Okay. We have a function coded GPIO, which stands for grid plate in and out. Grid current, plate current, grid current, plate current, input power, meaning drive power, and output power, return. There's a snapshot. Grid current 29 mils, plate current 1.0 amperes, drive power 42 watts, and power output 1473 watts. I have this loaded even a little more lightly than its normal condition because in normal loading the drive would be closer to 50 watts. Let me readjust that just off camera for a minute. Now another possibility here, if you're operating remote control and you have nothing else to watch on the computer, maybe you want to keep continuous monitoring of your amplifier basic operating conditions, the GPIO conditions on a continuous basis. In that case, we type in the command GPIO space on, return, and then once a second approximately we get a rundown of all the parameters. Now I apply power. You see we have 1560 watts. Let me adjust the output power a little bit down. There, 1473 watts out, 50 watts of drive, 27 mils grid current, 1.13 amps plate current, all very normal. And if I want, I can leave it in this mode, monitoring amplifier operating conditions continuously. To stop the progression, I'd simply enter the command GPIO off. Now, if your transmitting site and antennas are up out on a mountain somewhere, miles away, you may wonder what kind of shape your antenna's is in. I've already shown you that by just typing power return we can get the forward power. Now we can do the same thing. Reflected power, 10 watts. Well, that 2 weekends I spent matching this new beam paid off. Let's try the tri-bander. Yes. Well, let's demonstrate. Let's try something else. I'm going to move the transceiver frequency to the high band edge up around 14,340 and key it briefly. You see that the amplifier moved, indicates 340 measured, and so forth, and we're still on antenna D4. Now let's see up here what we have for reflected power. I happen to know that at this part of the band it isn't as good, so let's just take a shot of it at 1000 watts so it'll be easy to calculate the reflected power. Let me see what I have. PWR 1000 watts, pretty close, 1003, and reflected 55 watts. Not so good. Well, 5.5%. What does that correspond to? SWR of about 1.5, 1.6, something like that. Not bad for the extreme band edge, and not bad to be able to tell that remotely from your amplifier, especially if your antennas are in a winter storm up on a mountain someplace. Let's go to the other band edge, down close to 14.0. No signal there. And let's do the same thing. Key it up. It says 14.0, but I'm really a little above the band edge. Let's set it to about 1000 watts. See what the power is. PWR, pretty close. And let's see what P reflected is. 28 watts, or a little less than 3%. SWR of 1.3, 1.4. And maybe I should go into the antenna business. Nice big 5-element beam, 60-foot boom, with 3% reflected power on one band edge and maybe 5% on the other edge. Not bad, huh? I mentioned before that there are quite a number of other commands that we can execute remotely, either locally, that is, for the computer, or over some sort of a long line or a radio link. For example, we can command a band change without exciting, without driving the amplifier. Let's say we're now on 20 meters, band 5, we want to go to 10 meters, so it's band 9, return. Now we're on 10 meters, where the last frequency used was in the 28.2 range. And the amplifier has gone, as it always will, back to the most recent frequency used on a previous band. Let's say we want to go to 40 meters. That's band 3. Here we are. Previous frequency used, 7050. There are a great many monitoring functions possible that I haven't demonstrated. I might just show one that you ordinarily wouldn't use, but some of these have special command codes. So, and I don't pretend to know them all. But let's say ADS filament. That tells us that the filament current is 2.95 amperes, and since 3.0 is absolute nominal, why, that's fine. This is most useful in the event that one were to suspect that a tube heater had opened up. The current would only be half. That's a very unlikely event, but the software designer saw the possibility and included it. We can also remotely tune and load the amplifier, as I had indicated before. We can, for example, change the loading control setting by saying load up. We can change the tuning control, or load down for that matter. And this tells us what the final position is after that change. We can change the tune capacitor position up or down. We can see where our tuning position is. We don't give up the flexibility of the Digital Antenna Selector through remote operation either. I've just put on the screen, I've selected antenna A1, but if I'm on 20 meters and I'm using my normal Big Yagi, let's say it happens to be remoted from the operating location, I'm on antenna D4 and I want to try the tri-bander. That's antenna A1. It's that easy by keyboard. And of course, if I'm through with an operating session and for some reason I want to take the amplifier offline before I shut down, I can go operate off, and I'm in the standby mode. And if I'm through for the day, why not just say AC off, report, and there we have it.